Okay, Wildcats. Today we're looking at Tuesday, March 27th, Logarithmic Properties on page 67. All right, if you would, take a moment to update your table of contents. All right, now your table of contents are updated. Let's take a look at the notes. All right, so on page 67, Logarithmic Properties. So to go from exponential to logarithmic. So let's look at the individual variables themselves. So the b in exponential is here in the logarithmic equation. Okay, so now the a is here in the exponential equation, and it's here in the logarithmic. So this is really just all about seeing if the a is here in exponential, the a is here in the logarithmic, okay? And then the x is here, and it's here. So that shows you how to go from exponential to logarithmic. All right, so here it says the log of a product is equal to the sum of the logs of the arguments. Okay, so if we have log base b of x times y, that's rewritten as log base b of x plus log base b of y. All right. Here we have the log of a quotient is equal to the difference of the logs of the arguments. So if we have log base b of x divided by y, that's written as log base b of x minus log base b of y. All right, now it says the log of a number raised to a power is the same as the power times the log of the argument. So if we have log base b of x raised to the p power, that is p times log base b of x. Uh-oh, page turn. There we go, back on track. All right, so now here we have if the log base and the argument are the same, it is always equal to the power. So since the log base and the argument are both b, so the same, we say that this is 1 times p, or we can just say p. Okay, so here the log base 2 and the argument 2 are the same, so this is basically 1, and so this equals 6, so we can say that 6 is equivalent to x. Now, if the log base and the argument are the same, it is always equal to the understood power of 1. So, log base b, so the base and the argument are the same, so this equals 1. So, log base 2 of 2 equals 1, so we can say that 1 equals x. All right, now the change of base property. So basically that says that if we have log b base of n, that can be written as log of n divided by log of b. Okay, so log base 4 of 32 can be written as log of 32 divided by log of 4. And then log base 2 of x plus 1 can be written as log of x plus 1 divided by a log of 2. All right, so that goes over all of the logarithmic properties. So now let's use those on the examples. All right, so now let's look at example 1. So here we're going to rewrite in exponential form. Okay, so to do that, what we might do is exponential form, you might write that as b, and actually let's write it here, b to the x equals a, and then logarithmic form is log base b of a equals x. So we're in this form, and we want to go to that form. So here we can see the b is 2, so that's 2 to the x is 3, so that's 2 to the third, equals the a value, which is 8. Okay, so same thing here. So the b value is the 4, so that's 4 raised to the x value is 1/2, so 4 to the 1/2 equals the a value, which is 2. And then last one, which you might take a moment to try it on your own. All right, so now example 3. So then the b value is 2, the x value is 3, and the a value is x. All right, so now we're going to rewrite in logarithmic form. So here we're looking for, we know it's log, so log, we're looking for the b value. So the b value is the 2. Now we're looking for the a value, which the a value is 8. And then the x value is 8. Oh, I'm sorry, 3. All right, so now example 5. So again, we're going to look for the b value first. So the b value is 5. The a value is 1/25 equals the x value, which is -2. All right, so you might try example 6 on your own. All right, example 6. So again, log basis 4. The a value is 2, and the x value is 1/2. All right, so now we're going to evaluate. So basically, the way you look at this is that's kind of why we looked at exponential to logarithmic. We can actually convert this to exponential form to understand what the value equals. So basically, 5 is our base. Let's call this x. Let's say it's equal to x. Okay, so that's 5 to the x power equals 125. So basically, you're asking yourself, well, what power do you raise 5 by to give you 125? So the answer is 3. So x equals 3. And so the same thing here. We're going to convert this to exponential to understand what we're missing. So we're going to say it's equal to x. So we know that 4 to the x equals 1/4. So you ask yourself, well, what do you raise 4 by to give you 1/4? Well, in order to get 4 into the denominator, it has to be a negative exponent, and 4 to the 1 power is 4. So x equals -1. All right. Now here we can actually use the statement, if the log base and the argument are the same, it's always equal to the power. Or we can say that if the log base and the argument are the same, it's always equal to the power of 1. So basically, this becomes the power of 1. So then it's just 27. All right, example 10. So now we're going to expand. Okay, so we're multiplying. So we know we're adding, but then we also have the raised to the power here. So we can first start by writing this as log of x plus log of y plus log of z to the second power. But we need to move the 2 to the front, so then that's log of x plus log of y plus 2 times a log of z. All right, so this is the quotient rule, which you know is different. So that's log of x minus log of y to the 6, but we need to move the 6 to the front. So then that's log of x minus 6 log of y. All right, example 12. Now it says we want to condense. And then if we can, simplify. Okay? So we're adding here, so we know that's going to be multiplication. So that's log of 2 times 11 times 7, which if you multiply, 2 times 11 is 22, times 7 is 154. And that's as simplified as possible. All right, example 3, we're subtracting, so we know to divide, so that's log of 7, but here we have to move the 2 here, so divided by 12 squared, which is log 7 divided by 144, and that's as simplified as possible. All right, example 14, we're adding, so then we have that becomes condensed as multiplication. So log base 6 of 4 times 9, which we're going to multiply that. So that's log of 6 to 36. Well, here we know that we can make that equal to x. And so then we ask ourselves, well, 6 to what power equals 36? So that's 2, so x equals 2. All right. So then here we have subtraction, so that becomes division. So that's log base 5 of 100 divided by 4, which is log of 5 of 25. So we know, and we can set that equal to x. So then we know 5 to the x power is equal to 25. So you ask yourself, well, what 5 raised to what power gives 25? So x equals 2. All right, last two examples. Now it says use the change of base to evaluate. So that becomes log of 8 divided by log of 2. Now, when you put this in the calculator, they have this. All they have to do is have the same base. So you could do log base 2, log base 3, log base 4. It doesn't matter. But when you put in the calculator, you should get 3. Okay? And then same thing here, log of 16 divided by log of 8. And if you put in the calculator correctly, you should get 1.33 repeating. All right. So with that, you have two options. You can, if you understood our example, start working on an assignment. If you have some questions on the examples, you can wait to class to answer or ask some questions on examples, and we can go over the assignment together. Okay. So with that, have a wonderful Wildcat day.